Satukan cita, kobarkan semangat bagai pelita bagimu negeri, terus berkarya, Nusantara kan jaya. Dan suci padamu negeri, Ibu Pertiwi lestari. Senyum semesta indah terkembang, pertambangan karya nyata gemilang. Teguhkan tekad, satukan cita, kobarkan semangat bagai pelita bagimu negeri, terus berkarya, Nusantara kan jaya. Bakti dan suci pada negeri, Ibu Pertiwi lestari. Senyum semesta indah terbang, laju warni cerah gemintang. Politeknik energi dan pertambangan karya nyata gemilang. Karya nyata gemilang. Wahai putra-putri Pertiwi, para punggawa bangsa, jaga energi untuk negerinya. Jujur, cerdas, terampil, dan bijak mengolah, wujudkan nilai tambah. pertambangan ESDM gemilang. Wahai putra-putri pertiwi, para punggawa bangsa, jaga energi untuk negeri, nyala sepanjang masa. Nusantara nan kaya, bukti anugerah mineral melimpah ruah. Jujur, cerdas, terampil, dan bijak mengolah, wujudkan nilai tambah. Generasi emas putra-putri cemerlang, masa depan luas terbentang. Bersama Politeknik Energi dan Pertambangan ESDM gemilang. Bersama Politeknik Energi dan Pertambangan ESDM gemilang. ESDM gemilang. Wahai putra-putri pertiwi, para punggawa bangsa, jaga energi untuk negeri, nyala sepanjang masa.
Hai guys, kenalin nih, ada kampus baru namanya PP Bandung. PP Bandung merupakan politeknik vokasi di bawah Kementerian Energi dan Sumber Daya Mineral. PP Bandung berdiri pada tahun 2019 di bawah Badan Pengembangan Sumber Daya Manusia, Kementerian Energi dan Sumber Daya Mineral. Program studi yang tersedia yaitu D3 Teknologi Geologi, D3 Teknologi Pertambangan, dan D3 Teknologi Metalurgi. Pada tahun 2022, PP Bandung berhasil mendapatkan akreditasi baik untuk program studi dan institusi dari BAN PT. PP Bandung gak kalah loh sama kampus lain. Kita punya program unggulan yang bertujuan untuk menciptakan lulusan yang berkompeten di bidangnya. Dalam kurun waktu 6 bulan, sudah 60% dari lulusan PP Bandung telah terserap di berbagai industri energi dan pertambangan. PP Bandung membuka 5 jalur pendaftaran mahasiswa baru nih, yaitu jalur PSB, jalur TPU gelombang pertama dan kedua, jalur UTBK, dan jalur kerjasama industri. Pantau dan ikuti sosial media kami di www.ppbandung.ic.id, Instagram @pp_bandung, Facebook dan YouTube PP Bandung. Dan kamu juga boleh banget buat WA kami di 0822 1999 5001. Kami tunggu ya.
Selamat pagi, Pak Asep, Bu Imel.
Pagi Pak Asep.
Perkembangan pembangunan sektor pertambangan di Indonesia semakin dinamis dan maju. Oleh karenanya, kebutuhan sumber daya manusia yang handal di bidang energi dan pertambangan sangat dibutuhkan. Politeknik Energi dan Pertambangan Bandung hadir sebagai kampus unggulan dan menjadi lembaga pendidikan yang mengkhususkan diri di bidang energi dan pertambangan. Berlokasi di tengah kota Bandung yang terkenal sebagai kota pendidikan. PEP Bandung adalah lembaga pendidikan tinggi vokasi di lingkungan Kementerian ESDM yang memiliki komitmen tinggi menjadi politeknik terbaik bidang energi dan pertambangan di Indonesia, guna melahirkan lulusan yang memiliki kompetensi tinggi dan siap kerja. Saat ini PEP Bandung memiliki 3 program studi dalam jenjang pendidikan D3, yaitu Program Studi Teknologi Geologi, menitik beratkan pada inovasi di bidang eksplorasi mineral dan batu bara, geoteknik, hidrogeologi, mitigasi bencana geologi dan geoinformatika berbasis ilmu terapan. Program Studi Teknologi Pertambangan menitik beratkan pada inovasi perencanaan tambang, operasi tambang, dan pengelolaan K3 lingkungan pertambangan. Program Studi Teknologi Metalurgi menitik beratkan pada inovasi dan rekayasa proses pengolahan dan pemurnian mineral hingga menjadi logamnya, pemanfaatan batu bara, analisa laboratorium, dan pengembangan proses metalurgi ekstraktif. Semua program studi tersebut disampaikan oleh tenaga pengajar yang profesional, tersertifikasi, dan ahli di bidangnya masing-masing. Selain memiliki perpustakaan dan ruang kelas nyaman yang mendukung suasana akademik yang efektif dan kondusif, PEP Bandung juga memiliki berbagai laboratorium khusus, seperti Laboratorium Mikroskopis Mineral dan Batu Bara, Laboratorium Geologi Mineral dan Batu Bara, Laboratorium Pemboran untuk Peledakan, Laboratorium K3 dan Lingkungan, Laboratorium Mekanika Tanah, Laboratorium Metalurgi, Laboratorium Peledakan, Laboratorium Komputer, Perpustakaan, dan kelas yang nyaman yang memberikan suasana akademik yang efektif serta kondusif. Dengan komposisi pembelajaran 30% teori dan 70% praktek, proses pembelajaran tidak hanya dilakukan di dalam ruangan kelas, tetapi dilakukan juga melalui kegiatan praktik di lapangan, praktik kerja industri atau magang di perusahaan-perusahaan pertambangan dan metalurgi, memberikan peluang yang baik untuk pengembangan skill dan pengalaman para mahasiswa PEP Bandung agar siap terjun di dunia kerja. Lulusan PEP Bandung diproyeksikan dapat mengisi posisi-posisi strategis di bidang energi dan pertambangan.
Dengan adanya dukungan fasilitas yang memadai, membuat kita lebih mudah dan lebih fokus memahami materi selama kegiatan belajar mengajar.
Suasana belajar di sini sangat asik dan menyenangkan, karena di sini kami sering melakukan kunjungan industri ke perusahaan dan instansi terkait pertambangan, sehingga belajar di sini terasa tidak monoton.
Halo, good morning, Dr. Saparas.
Hi.
Hi.
Good morning, everyone. Yeah.
Good morning. Finally, we can meet
Yes.
directly.
Selamat pagi, Dr. Saparas.
Directly.
Good morning from my side.
Virtually. Selamat pagi.
Selamat pagi. Sehat-sehat, Ibu?
Alhamdulillah sihat. Bapak-bapak sihat.
Alhamdulillah. Sehat, alhamdulillah. Gimana? Ini di Kuala Lumpur atau di manakah?
Saya di Jeli, Kelantan.
Oh, di Kelantan.
Kelantannya
Belah utara ya?
northern part of Malaysia. Yeah.
Yeah.
Oke.
So, Pak Asep is our director, PP Bandung, Bu Dr. Saparas, and Bu Imelda, she's vice director.
Good morning.
Ya.
Good morning,
Ibu Saparas.
Bu Imelda.
Ibu Saparas, nanti mungkin kegiatannya akan dibuka Bu Imelda, karena saya harus ada rapat yang lain, sehingga saya hanya menyapa Bu Saparas saja yang sudah luar biasa berkenan memenuhi undangannya teman-teman di PEP Bandung. Terima kasih sekali lagi Bu Saparas.
Terima kasih juga atas undangan ya. Terima kasih.
Ya. Semoga ini jadi langkah awal untuk kita terus bekerja sama ya antara teman-teman di Malaysia dan teman-teman di Indonesia. Terima kasih sekali lagi Bu Saparas.
Insyaallah.
Ya.
Ya.
Ya. Silakan Pak Lumban, Bu Email, nanti dilanjutkan acaranya ya.
Siap.
Terima kasih.
Terima kasih Pak Asep.
Morning, Bu Saparas.
Ya, Murni.
Ketemu via Zoom. Kita ketemu via Zoom.
Jumpa lagi kita ya.
Jumpa lagi, Bu. Kapan ke Indonesia?
Wih, yang ke Bandung gitu, yang akhir sekali.
Ditunggu oleh Pak Radit di Indonesia.
Ya.
Bapak, Ibu, bisa kita mulai?
Ya, boleh.
Silakan.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam.
wabarakatuh.
Good morning, ladies and gentlemen, best wishes for all of us. It is an honor for us that we have His Excellency, the Director of Polytechnic Energy and Mining Bandung, Mr. Dr. Asep Rahman, STMT. Respectable, the Head of Geological Technology Major, Mr. Dr. Denny Lumban Raja, Eskom MT. Honorable our speakers today, Miss GS TS Dr. Saparas Binti Daliman. Respectable of all of the lecture of Polytechnic Energy and Mining Bandung and the all participant of this seminar. First of all, let's thank the Almighty Allah Subhanahu wa Ta'ala who has given us some mercies and blessings so that we can attend this webinar with the theme Identification of Mining Area using Landsat satellite data with machine learning on Google Earth Engine and digital image processing and its significance in remote sensing and GIS. Allow me to introduce myself. My name is Tebetorik Zikrifati, a geological technology student of 2003, who will be the host for this morning webinar. The schedule of today's event are as follows. First, speech by Director of Polytechnic Energy and Mining Bandung, Mr. Asep Rahman. Second, speech by Head of Geological Technology Study Program, Mr. Denny Lumban Raja. Third, speech by Ms. Saparas Binti Daliman and Mr. Denny Lumban Raja. And the last, the photo session and closing. Firstly, I would like to invite the Director of Polytechnic Energy and Mining Bandung, Mr. Asep Rahman, to delivery, but unfortunately, Mr. Asep can share his speech today and will be represented by Ms. Imelda to speech and officially open the webinar session. Ms. Imelda, the time is yours.
Okay, thank you, Tariq. Yeah, good morning, everyone. Thank you for coming to this international webinar. Thank you. Good morning, Miss GSTS Dr. Saparas Binti Daliman. And also, good morning. She is from University Malaysia Kelantan. Yeah, and also to Dr. Denny Lumban Raja from Bandung Energy and Mining Polytechnic, our campus. Yeah, thank you for joining our website today to share the knowledge and also the experience here with the students and also with the lecturer of PAP Bandung. I would like to thank you also to Gypssum for facilitating this event, international event, so that today we can attend the international webinar with the theme of Revolutionizing Remote Sensing and GIS, unveiling the power of digital image processing in mining area identification through Landsat satellite data machine and machine learning on Google Earth Engine. I think this theme is very powerful, especially to understand the digital image processing in remote sensing and also in GIS, and also to understand the using of Landsat satellite data with machine learning on Google Earth Engine to identify the mining area. So this is really related with our lecture here in Bandung Polytechnic, ya, in PIP Bandung. I hope everyone will enjoy this webinar and gain a lot of this sharing session. I officially open this international webinar. Thank you and good luck.
Thank you, Miss, for your speech. Further, we welcome the head of the Geological Technology Study Program, Mr. Denny Lumban Raja, to deliver the speech. Bapak Denny, please.
Okay, thank you, Tori. Since I am the one of the speakers, maybe I will convey it during my presentation, Tori. Okay, let's continue, Tori. Hello, Tori. Can you hear me?
Okay, noted. All right, now are on the main agenda of seminar about identification of mining area using Landsat satellite data with machine learning on Google Earth Engine and digital image processing and its significance in remote sensing and GIS with Miss GS TS Dr. Saparas Binti Daliman and Mr. Dr. Denny Lumban Raja Eskom MT. Before I hand to all the audience, please set the audio off or mute while we are in the webinar session. Today's seminar will be guided by our moderator, Ms. Nabila Fauzia Hardian, my colleague from Geological Technology student class of 2023. Nabila, the session is yours. Big applause, please.
Thank you, Tori. Hi, everyone. Good morning. My name is Nabila Fauzia Hardian, a geological engineering student from Polytechnic of Energy and Mining Bandung. And I'm in charge as today's moderator for this webinar. And I would like to welcome you to Gypssum. Before we begin, I would like to share the house rules for this webinar. First, deliver to the audience. Before starting the material, please activate the camera feature with the virtual background that has been shared. And to the audience, to always set the audio settings to mute so that when the speaker delivers the material, it can run smoothly. And if any of you want to ask question, please use the raise hand feature or type your question on the chat box. And now, please let me introduce you to the first speaker, Miss GS Dr. Saparas Binti Daliman. She has She has so many working experiences such as senior lecturer, DS51 permanent on Faculty of Earth Science in University Malaysia Kelantan, and lecturer DS45 permanent Faculty of Earth Science, University Malaysia Kelantan, and lecturer DS45 permanent Department of Geoinformation, Faculty of Geoinformation and Real Estate UTM. Lecturer DS45 Contract Department of Remote Sensing, Faculty of Geoinformation Science and Engineering. Research Assistant, Department of Geomatics, Faculty of Geoinformation Science and Engineering. Research Assistant, Department Microelectrics and Computer Engineering, Faculty of Electrical Engineering and UTM. And please welcome our first speaker, GSTS Dr. Saparas Binti Daliman, that will tell us about digital image processing and its significance in remote sensing and GIS. The time for presenting the material is 50 minutes.
Okay. Thank you, Nabila. Okay, can I share my screen? Right. Can you see my screen? My slide?
Clearly, Dr. Saparas, clearly.
All right. Okay, thank you. Okay. Okay, good day, everyone. Good morning. Assalamualaikum warahmatullahi taala wabarakatuh. Okay, I am Shaparas binti Daliman. Usually in UMK, my students just call me Dr. Shah. Okay. So today, thank you for inviting me. And I would like to share. Actually, it's I'm not really the expert, but I just want to share what that we have done previously in UTM and also in UMK. Okay, so this is digital image processing and its significance in remote sensing and GIS. I'm sorry. Earlier, I was told that I have given 2 hours to deliver this talk. However, if in 50 minutes, I'll try to summing up this slide. Okay.
No, Miss. Dr. Saparas, you can, you have a lot of time today.
Oh, all right. Okay.
You can deliver, to 30 minutes or maybe 1 hour. It's no problem. It's at all.
All right. Inshallah. Okay.
Yeah. Okay, Dr. Saparas.
All right. Okay, so just what like to share, this is our faculty, okay, the campus of UMK Jelly campus. And here, if you can see, this is our globe of Earth, where this is uh, our kind of globe in Faculty of Earth Science, okay. All right, so the overview of digital image processing here, or usually we are calling DIP. I would look into definition of DIP, the significance in remote sensing and GIS, and the key applications in environmental monitoring, land use analysis, and disaster management. And also towards the end of this slide, I will just 2 slide of the remote sensing in mineral exploration. Okay. So what is actually digital image processing? It is actually if we use the computer algorithms and techniques to manipulate, enhance, analyze, and interpret digital images. Okay. And it is a field of study that focuses on the processing of images acquired from various sources, okay, such as the digital cameras, the satellite or aerial sensors, and also there are also broad applications such as the medical imaging devices and also more of it, right? Okay, and the primary objectives of DIP include improving image quality, extracting meaningful information from images, enabling automated analysis and interpretation of visual data. And digital image processing has numerous applications across various fields, and usually in remote sensing, the medical imaging, the computer vision, and also the multimedia, where all in terms of if we look into of the movie, right, and also even the all those game nowadays, okay, all those are using all the digital image processing, so that all that you see is very beautiful graphic of it, right? And the significance of this digital image processing in remote sensing and GIS, it is actually a pivotal in remote sensing and GIS for several key reasons. Okay, the first one of it is the information extraction, where the DIP enables the extraction of valuable information from remote sensing. Okay, let me highlight. Okay, where from remote sensing, and this of remote sensing imagery, where this information forms the foundation for GIS database. We can look or see that the remote sensing images is actually the source of the data, and from that data, remote sensing images, with the digital image processing, we have to interpret it, okay, to analyze it, to process it, okay. Then we extract the information. From that information, then it will become for the GIS database, okay. And also the second is on the data enhancement. Okay, the IP techniques improve the data quality. Okay, because usually when we get the data, the raw data, okay, so the raw data sometimes it is blur, okay, and sometimes it has a cloud, okay, or usually it is blurry lah. And then we have to reduce the noise and correcting distortions. So if we want to have a much more accurate analysis, okay, to have to improve the data quality, so we have to do the data enhancement. Okay, next is on the quantitative analysis. Okay, DIP allows for quantitative measurement. Okay, because usually in the statistical analysis, there are qualitative analysis and also the quantitative analysis. And usually the digital image processing, when we have all those data information, we can use it for the quantitative analysis. Okay, so based on the measurement and also the analysis of attributes, so we can make the quantitative analysis. Okay. And also on the automation, okay, where the automation of repetitive tasks. Because usually when we do sort of the image processing or any processing or analysis, there are repetitive tasks. The task is repetitively will do the same thing for every features, let's say, or every process or every data. So when we can make this automated, when we want to do the automated of repetitive tasks, then we need to do or using the digital image processing. Okay, usually when we are doing the classification and also the change detection, it has the similar tasks. Okay, so in handling large volumes of data in both fields, so usually we are using the digital image processing. Okay, the IP and GIS integration is crucial for accurate spatial analysis, and this is when we are using for georeferencing, the temporal analysis, the mapping, and also resource management. Okay, when we are talking about georeferencing, we are ensuring the remote sensing data aligns with the GIS data accurately. Okay, because usually when we have the remote sensing images, we have to make sure that it is the same location as it is in the real world. So this is where the georeferencing refers to. Okay, and next is on the temporal analysis, where DIP aids in comparing images over time. Okay, where usually this one we are doing for the change detection. Okay, and also for the, let's say that we want to look, such as if there's a disaster, okay, and we want to look what is the before and after event of it. So this is where we compare images over the time. Okay, and also in mapping, the IP is fundamental for creating thematic maps, okay, and visualizations, where this is the backbone of GIS for decision making. Because usually when we are talking about GIS, the end product of GIS usually the map, okay, and when we are talking about the map, so the IP is the most important, okay, process when we are dealing for the mapping of because we want to create the accurate map, right? Okay, and finally for the resource management, the IP assists in resource management such as agriculture and forestry by monitoring and assessing crop health and resource growth. Okay, usually because when we are dealing with the remote sensing, okay, there are the spectral bands of different, and we can look into the vegetation analysis of it. Okay, and we can identify based on this vegetation crops and so on, we can identify that this crop is in health or have deteriorate. Okay. Okay, DIP has a profound impact on decision making and problem solving in various domains, where in disaster management, environmental monitoring, scientific research, and also decision support. Okay, and if we look into the disaster management, DIP helps identify affected areas, assess the damage, and also plan response efforts during disasters. Okay, because when we are looking based on the remote sensing images, okay, by visually we can identify the affected areas, but when we are using the digital image processing tools, okay, we can identify accurately where, because the affected areas has a significance detail of it, right? So we can use the DIP to identify and also assess the damage. And usually when we are using when we are looking for the disaster management, usually we are doing the change detection, okay? And for the environmental monitoring, okay, DIP is instrumental in monitoring environmental changes, okay, like deforestation, urban expansion, and also natural disasters, okay? Whilst in the scientific research, DIP is widely used in scientific research, including climate studies, ecological modeling, and geological research. Okay, also such as for the mineral exploration. And also in using for the decision support, okay, when we are already providing detailed spatial information, DIP assists in decision makers in urban planning, okay? Because when we already have the information, we already know the map of a particular area, and we want to expand the area. We want to look into what types of the transportation that needed in that area. So DIP can assist in decision makers, okay, for the transportation and also for the infrastructure development. Okay, so DIP significance in remote sensing and GIS lies in its ability to extract information, enhance data quality, automate tasks, integrate with GIS, and also it contributes to real-world applications across various domains. Okay, its impact extends to decision support, okay, as previously mentioned, the resource management, the environmental monitoring, and also the scientific research. And what is the role of remote sensing and GIS actually? So we can look at what are the relationship between the remote sensing, the GIS, and DIP. I will show you later. And how actually the DIP enhance the utilization of remote sensing data in GIS. Okay, this is where how the relationship it's looked into, where the synergy of remote sensing, GIS, and DIP, where for our knowledge, remote sensing involves capturing data about Earth's surface from a distance, okay? So remote sensing, usually we are referring to the satellite images or from the aircraft or also from the drones, okay? So it provides raw data in form of images, and also it can also be formed from the spectral data or also in point clouds, okay? Usually from the drones, we are referring to that it is a point clouds data, okay? And DIP, as you previously, it is a processing analyzing digital image, okay? And GIS, or Geographic Information System, it is a technology to manage, analyze, and visualize spatial data. What's meaning of the spatial data is actually the data that have a location, okay? So the GIS will integrate data from various sources. So the various sources coming from the remote sensing or also coming from, let's say, from the temperature or all those data. So this is to support spatial decision making. And this is the workflow from the remote sensing and GIS workflow, okay? So if we want to know where is the remote sensing here, this is the remote sensing part of it, where usually in remote sensing, we need the sun, okay? And the sun is actually for the passive remote sensing, okay? While if we are looking in the active remote sensing, such as radar, then the sun is not needed lah, okay? But usually, if you are using the Landsat, then need the sun. So based on the sun, the solar radiation from the sun, so because we are looking on the earth, okay, so this is the satellite or the platform of the remote sensing to capture the image. So once we capture the images from the earth, so the satellite will transmit the data to the ground station. So the ground station and data warehouse will do the pre-processing here. Okay. Okay. So what is the pre-processing? The atmospheric correction, the radiometric correction, geometric correction, the georeferencing. Okay. All those is actually part of the digital image processing. Okay. This is where the integration, how the remote sensing, the digital image processing. And finally, where is the GIS? So here, part down here is where the GIS we are looking at the application of it. So the spatial data modeling along with other GIS data set and also the algorithm development or the multispectral classification, where this is where the application or where you want to look into. Okay. All right. So in terms of the workflow and applications, okay, I already explained it in terms of the picture. Okay, so actually this is where the explanation of how the data acquisition, where remote sensing collects the data, right? And the data integration, where the process remote sensing is georeferenced and integrated into GIS. Okay, the analysis and decision making, where GIS is used to perform spatial analysis, create the maps, and for the support decision making processes. And finally, after the GIS, where we are looking for the applications of it, where the synergy between remote sensing, the DIP, digital image processing, the GIS, okay, where this is where we look into for the applications. The applications is various of it. Just to mention some of it, it is the environmental monitoring, urban planning, disaster management, natural resource management, agriculture, much more of it. Okay. Okay, so we are now looking into the image acquisition and pre-processing, where we are going to look into the image sources, the pre-processing steps, and also the image registration and integration with GIS. Okay, so what are the image sources? Which one that we have to look? Either are we going to use the satellite images or the aerial imagery? Okay, so there's a big difference actually, okay, between the satellite imagery and also the aerial imagery. Okay, where when we are talking about the satellite imagery, of course, it is from the satellite, right? And if we are looking for the aerial, so it is captured using cameras on the aircraft. The aircraft is usually either we are talking about the airplanes, the helicopters, or also the drone. Okay, and in terms of the coverage, of course, if we are talking from the satellite perspective, it is very, very far away and up from our Earth, right? So it will provide a global perspective and capture a much more large areas of countries or continents. Okay, but if we are using the aerial imagery, it offers flexibility to capture specific. So if it depends on your application, either you want to look in the broadened horizon or you just want to look into a very specific location. Okay. In terms of the resolution, typically, I say, it is coarser, ranging from 30 centimeter to 30 meters. Okay. The most high resolution is 30 centimeter that we can get from the satellite. Okay, and of course, when we are using the aerial imagery, using the airplanes or the helicopters or the drone, we can have a much higher spatial resolution in terms of centimeters of to few meters. Okay, and the frequency, it will be regular because the satellite is orbiting the Earth, so it has depends on the revisiting of the satellite on that particular location. And for the aerial imagery, it will be acquired as needed for the projects. Okay, right. In terms of the cost, okay, we have to look in terms of a broadened view. Okay, After the cost effective, okay, for large scale applications, of course, the satellite is very, very costly. But when we are looking in terms of very long term applications, then it is cost effective. Okay, but in terms for when we are using the aerial imagery, it is more expensive due to aircraft operation and maintenance. Okay, and in terms of the applications, the satellite imagery usually will be used for land cover mapping, the global scale observations, and also environmental monitoring. And for the aerial imagery, usually it is ideal for urban planning, infrastructure inspection, disaster response, precision agriculture, because we want to look very precise, very particular on the location. And even for the mineral exploration, we want to look into a very high spatial resolution. We want to look a detailed land use analysis. So usually we go for the aerial imagery. So in terms of the choice between either the satellite or the aerial imagery, usually it all depends on what your project needs. Okay, so many projects benefiting from combination of both sources. Okay, usually when even though that they are using the aerial imagery, sometimes they're also referring to the satellite imagery as well for the broader perspective and also for comprehensive data acquisition. Okay, the image sources type of sensors. Okay, just for overview that the satellite have an optical, okay, has also the thermal infrared and also have a radar. This is where I mentioned if we are using the radar or radio detection and ranging, we don't need the sun, okay, because the radar is already transmit its own microwave signals. So we can use the radar either all weather, day or night imaging. Okay, but then usually the radar it have a different image processing algorithm to deal compared when you are using optical or also the thermal infrared. Okay, the optical it will only capture visible and near infrared light, and this is where we are using the sunlight. Okay, and thermal infrared it will detect emissions in the thermal infrared spectrum. And this one usually for monitoring the temperature variations. And in terms of the satellite, it is the satellite name MODIS and also Aster. Okay, Landsat is from the optical, all right? Okay. Okay, there's also LiDAR. Okay, LiDAR, light detection and ranging, where this LiDAR is emit laser pulses. Okay, this is most of the latest technology using in the remote sensing and used for topographic mapping, forestry, urban planning, and this one is much more high resolution and high spectral of it. Okay, because it can create detailed 3D point clouds. Okay, an example of LiDAR is ALS and also TLS. Okay, LiDAR is not from the satellite. Okay, it's all either airborne or terrestrial. Terrestrial, which is the equipment is on the ground. Okay. Okay, in terms of the hyperspectral is very narrow and contiguous spectral bands. If this Landsat have up to 12, 13 band, okay, hyperspectral have more 100 of it. Okay, and this one valuable for precise material identification and mineral exploration. Okay, usually for the mineral exploration because it has a very, very distinct spectral, and we can look what kind of mineral that identified and classically can be detected by those specific spectral. Okay, and the example of hyperspectral is the Everest and also Hypsipyri. Okay, so the choice of sensor is actually depends on the specific application, the environmental conditions as well. Okay, either you want to look on a very, very clear you want to look, you do not want the cloud, let's say, such as, okay, so if you do not want to have the data that have the cloud, so usually we are going for the radar, okay, or you need to selectively on the Landsat, but then it's you have to pick on the cloud-free day lah, okay, and the type of data required leading to a diverse range of sensor technologies for various remote sensing applications. Okay, I want to go faster on these pre-processing steps in remote sensing. Okay, this is actually the pre-processing steps that need to be done when we are doing the remote sensing. And this is actually part of the digital image processing that you use in the pre-processing. So the geometric correction, radiometric correction, atmospheric correction, image enhancement, noise reduction, mosaicing, vegetation index calculation. Okay, this is very, very interesting, where we can look either the healthy or non-healthy of vegetation. And georeferencing already mentioned earlier, and also the temporal analysis also already mentioned earlier. Okay, so the GC, okay, geometric correction, usually we also mention it as GC, where the objective, we want to correct the geometric distortion here. Because when we are taking the pictures, okay, on the ground, okay, we the satellite is taking from different angle of it, okay, so it has either the angular side or from this side. So we want to make sure the picture that we get is correctly geometric on the ground. Okay, so we do the geometric correction. Okay, this can be done by using the auto rectification. Okay, and it's very important to ensure precise georeferencing for accurate spatial analysis. Okay, and radiometric correction, why we need to do the radiometric correction is actually we want to, because as I mentioned earlier, if we are looking for the satellite that use the sunlight, okay, from the sun to the earth, we have a very several layers of atmospheric, right? So it has absorption here, it has the scattering here, okay, the incident radiation. So all of this will be affected to the images that we receive. Okay, so what we have to do here is actually to adjust pixel values for atmospheric effects. Okay, because the atmospheric effects is coming from the scattering and absorption of light. Okay, and the methods that we are using is actually the calibration, where we convert the pixel values to radiance or reflectance and atmospheric correction. Okay, the importance is actually allows for meaningful comparison of pixel values across different images. Okay, this is what the meaning is. Okay, when we are comparing images from different years, okay, we would like to know the sunlight on years of 2023 and the sunlight in year of 2013 have a similar brightness. We cannot identify that, right? So this is where we want to adjust the pixel values so that the atmospheric effects have not influence the pixel. So we can compare the images without the radiometric effects. Okay, so we can compare it correctly. And for the atmospheric correction, okay, this is where the blurry images, okay, the left side here, and the atmospheric correction is what we do is to remove or reduce the influence of Earth's atmosphere on satellite or aerial image. Okay, usually the atmospheric correction can only be done for a haze or a very, very very light of cloud. Okay, but if the image is very cloudy, it kind of impossible to do the atmospheric correction. Okay, but we can do the mosaicing. There's also another part of the image processing that we can actually solve the problem. Okay, so to do the atmospheric correction, so the methods we are using the radiative transfer models where the dark object subtraction. We want to extract the ground of the images, right? So usually actually we subtract where the haze or the light of the cloud. Okay, so of course the importance of atmospheric correction to ensure data accuracy and consistency. Okay, this is the image enhancement. Okay, as you can see here in this image, from the left side to the right side, it is very different, right? And this is where the image processing have improved image quality for better visual interpretation analysis. Okay, so what we can do here is actually just a very simple one: contrast stretching or histogram equalization or spatial filtering techniques. Okay, this is all already have the algorithm and also the processing inside the software. Okay, and of course the importance to enhance image clarity and detail. Okay, this is the example of noise reduction. Okay, the noise reduction is actually we are referring to the clutter. If you are looking here up here, it have a very noisy image. Okay, very dot right that right. It's not very sharp. Okay, so denoising is actually the noise reduction technique. Okay, so the left is image with a very noisy image, and also the right side is after we remove the noise. Okay, how we do that is actually by filtering techniques. Usually we do the median or mean or Gaussian filters. Okay, so of course we want to enhance the data quality and helps reveal meaningful features. Okay, this is where the mosaicing. Okay, because the image of the satellite, okay, it has a very one layer of image, okay, for each location and also for each time. So we want to look into a broader one. So what we have to do here is if we have to mosaic it, where this is actually combine multiple images to create a seamless composite of a larger area. So like here, right? So this is from, let's say, from 6 of different images. So when we do the mosaic, so this is the image of combining these 6 images. Okay, this is the method is actually stitching individual images to form a continuous large image. Okay, and of course, the importance is to provide a complete view of the area, facilitating seamless analysis. Okay, this is where I want to share where the vegetation index calculation, where we can see here. Okay, this is one of example here. The NDVI. Okay, the NDVI is actually a normalized difference vegetation index. Okay, this NDVI is very popular one, where when we use this formula of near infrared minus red band, okay, wherever satellite that have the near infrared and also the red band, we can use this NDVI, okay, and divide with the NIR plus red. And if we are getting the formula, it's let's say more than 0.5 and above, we usually identify it as a healthy vegetation. Okay, but if the NDVI has less, let's say 0.14, this is usually we will identify it as a non-healthy vegetation. Okay, so this formula-based calculation using NIR red bands. So this supports quantitative analysis for the vegetation and also the environmental conditions. Okay, this is the georeferencing where we want to identify correctly what the image and also the location on Earth that we are referring to is actually the same one. Okay, so we assign the spatial coordinates to each pixel. Okay, so usually the methods is we have the ground control points, GCP, and also the GPS-based georeferencing. Okay, for this part is actually the temporal analysis where this example shows for each year of data from 1998 to 2009. And this is the temporal, which is we are looking different images for each year. Okay, so we want to analyze the changes over time. So from the remote sensing images and using the digital image processing, so we can compare what's actually different. Is there any changes? Is there any improvement? Okay, so from based on this temporal analysis, we can monitoring the land cover changes, the natural phenomena, and also the urban growth. Okay, this is actually the image registration when we are using with the GIS. So image registration is the process of aligning or geometrically correcting remote sensing or aerial image. Okay, so this image registration is actually sort of similar to the georeferencing. Okay, but usually we are using using the geometric correction to ensure precise alignment. So the image registration, when we integrate with the GIS, so once the imagery is registered and aligned to a common spatial reference, it can be seamlessly integrated into GIS. Okay, this is where once we do all those pre-processing using the DIP, and finally we can get the image and registered into the common spatial reference system, then we can use in the GIS. Okay, and after the GIS, we can do much more on the analysis part. Okay, so by combining remote sensing data and GIS, we can go for in-depth analysis, such as the land use or the vegetation health or urban growth or environmental changes or the mineral exploration. Okay. Okay, this is actually, I will go fast on this image analysis techniques, okay, where the image interpretation versus analysis, the classification, the change detection, and also feature extraction. Okay, so for the image interpretation versus the analysis, what is actually the different in terms of this is actually the visual identification versus automated processing. Okay, in terms of image interpretation here, we are looking for the visual examination of imagery. So if we process the the object of the image and so on, by visually, we can do that. But then if we are doing it using the image analysis, we are kind of systematic and quantitative examination. And this why we have to use the computer algorithm and techniques. Okay. And for the image interpretation, it focuses on the qualitative observation and understanding what is it. But then by using the image analysis, we aim to extract precise information and quantify characteristics. So if we are doing the image interpretation here, it all relies on human expertise and subjective judgment. Okay, when the expert that usually look into the remote sensing images and so on, it can normally identify where's the bridge, the land, the water bodies, and so on. But if you are the first time looking at the remote sensing images, sometimes you are quite confused what is actually this is referring to. So by using the image analysis, it can involves automation often requires minimal human intervention. Okay. So those for the image interpretation like visual inspection, magnification, and experience. And for the image analysis, it has all the software tools. Okay. So either you can use the software tools for the classification, for the feature extraction. Okay. The examples is such as this one. So identify, both of them can identify both, okay? But then based on either the visual or the automated processing. Okay, so the image interpretation versus analysis, the role of DIP in image analysis. So DIP enables the measurement of pixel values, errors, and distance. So it can also do the automate analysis, and also by the DIPE process image, it can seamlessly integrated into GIS. And for scientific research, of course, the IP supports the scientific research for data extraction, data analysis, okay, do the modeling, okay. So, of course, the role of the IP in image analysis is multifaceted and essential in various domains. Okay, this the image classification in remote sensing. Okay, image classification is very one of the popular and usually must do if you want to do the land use classification, if you want to look into the change detection, and also for the mineral exploration, usually also we do the image classification first and then we do for the mineral identification. Okay. Okay, so I want to go fast on this. So basically, image classification have the unsupervised, supervised, and object-based. And this is actually the example. The upper here is the raw images of satellite image. Okay, and down here is actually the classification of land use types based on image up here. Okay. So the classes here we can look, okay, if it is blue one, so here we can look at this is blue. So this is water. Okay. And if the green here, it is open space resident. So this is the example of image classification. So unsupervised classification is we do not need to give instruction to the classification. We just use the methods. We can just instruct the computer to do the classification. So this is the method here, generate ISO clusters, and then it will classify the ISO clusters. Very simple, okay? And the image clustering algorithm is a very common one, the K-means and ISO data. You just have the image and then just select the which one of the clustering algorithm that you want to use. And then next, you can just make what the number of groups that you want to generate. Okay, either you want to create 8 or 20 or 42. Okay, next is this is how the unsupervised classification it look into the spectral class of your image. Okay, and then okay, this is the explanation. I want to go fast. Okay, so this is the example of it. So this is the cluster. The unsupervised classification, it will look based on that cluster of different spectral, and it will just classify it into, let's say for this one, is into 15. Okay. All right. So from here, we need to identify what is actually the green one, what is actually the blue one, and so on. And so unsupervised classification here, it attempts to find classes in n-dimensional space. So if it is 15, 15 dimension. So if 10 or 5 or so, whatever that you want to do the classification. Okay. Okay, this is the image, the raw image. And next is the unsupervised classification. And this one is up to 15 classes. Okay, the supervised classification, we need to identify first. Okay, you as the user have to identify where this pixel belongs to what. Okay, this pixel belongs to, let's say, for the vegetation, this pixel belongs to the water bodies. Okay, so the software that use these training sites and apply them to the entire image. So this is where you supervise the classification. Okay, so you select the training areas, generate selection file, and also classify. There's also actually different algorithms that you can use. Okay, the first one you select the features. Next, you can pick what type of algorithm that you want to use for the supervised classification. So let's say for this one, we have the maximum likelihood, minimum distance, specific components, or also the SVM and also the ISO cluster. So if we look here, okay, this is the image, and also this is the supervised classification. And here, this is where the pre-chosen training sites, okay, we identify here is the seawater, this one, the sedimentation, okay, so we identify the training sites. Next is, it is also looking into what the spectral referring to, and the algorithms. Okay, this is the different algorithm using the minimum distance and also the maximum likelihood classification. So it looks have similar, but if we look closely, it has a very quite different of classification where we can see, okay, if we look, let's say here, somewhere here, and you compare it somewhere here. See, the minimum much more clearer on this classification, but then the maximum it kind of like a cluster or noisier here. Okay. So from this part, usually we are using the minimum distance classification. Okay, the object-based image analysis or OBR, okay, it is much more for the image that have high resolution. So instead of using on the pixel, we are looking on the objects. Okay, so object with different geometries. So once we have the object, so we can do the segmentation and then the classification. Okay, so the image based on the OBR, we look into the shape, texture, spectral, geographic context, or the nearest neighbor classification. Okay, which image classification techniques that we can use? Okay, either we have to use the supervised or unsupervised or the OBR. Okay, so usually if we have a high spatial resolution, usually we are looking or using the OBR. It is superior to traditional pixel-based classification. But then, if you are only having the medium spatial resolution and low spatial resolution, okay, you can just use the pixel-based. Okay, the pixel-based, which is the unsupervised or the supervised classification. Okay, I want to touch on the change detection. So actually the change detection is we are looking on the image of different years. Okay, this is 1990 and also this is the 2015. So this is we are looking on the NDVI. If we are looking here, the green in 1990 is much more, have much more, right? But in 2015, it has less. So meaning there's a changes. Okay, let's say probably there's a deforestation have occurred here. Okay. And the feature extraction is the process of identifying or specific objects. Okay. So let's say of this one where we want to look the delineation. Okay. From this image, so we look the features extraction here. So actually, first of all, kind of we want to do the classification first. So from here, you can look what are the x-axis. Okay, this is where it integrates into the GIS. Okay, what are the pixel value of it? And then the result of feature extraction from high resolution image. So we can select appropriate features and methods to successful feature extraction. Okay. All right. So finally, remote sensing for mineral exploration. For this, remote sensing identifies minerals and geological structures through spectral analysis. Okay, enable cost-effective exploration. But that's the challenge in the mineral exploration, where the resolution's limitation. So limited spatial and spectral resolutions may hinder the detailed identification of mineralogy. And also the cloud cover and weather interference, of course, in terms of mineral exploration, or also the change detection or the land use classification, it will affect. Okay. And this is the example when we are using the remote sensing for the mineral exploration. So let's say this is the one that you can highlight for the mineral based on the reflectance. The wavelength of the mineral is very different compared to the water and also the vegetation. So from the mineral, you can identify what is actually, is there any mineral over your remote sensing images here. So each pixel contains a sample spectrum. So we can identify the material present in the pixel by their reflectance. Okay, I think that's all from me. Thank you so much.
Thank you,
Okay,
Ms.
Dr.
Paras,
Denny.
for the insightful presentation.
Alright.
I'm sure our audience has learned a lot from you today. And now, please allow me to introduce the second speaker, Dr. Denny Lumban Raja, ESCOM MT. Mr. Dr. Denny Lumban Raja study and got Bachelor of Computer Engineering in 2002 at Bina Nusantara University and Master in Geodesy and Geomatic Engineering 2013 Bandung Institute of Technology. Doctor in Geological Engineering in 2021 at Pajajaran University. Mr. Dr. Daniel Lumban Raja, ESCOM MT, has so many experience, especially in computer. And he also has so many publications. And please welcome our second speaker, Dr. Daniel Lumban Raja, ESCOM MT, and he will tell us about identification of mining areas using Landsat satellite data with machine learning on Google Earth Engine. The time for presenting the material is 50 minutes.
Okay, thank you for a warm introduction, Nabila. Good morning, everyone. Can you hear my voice, Nabila? Okay. Once again, good morning, everyone. I see there's a lot of students from UMK, University Malaysia, Kelantan, right? Okay, good morning to the lecturers and of course for our students. It's a pleasure to be a part of this webinar. First of all, I would like to extend my appreciation to our distinguished guest speaker, Dr. Saparas. And thank you for having today. And we need to share your experience and knowledge, particularly in remote sensing and GIS. The presentation you provide was impressive and valuable. You have explained digital image processing very clearly, and it's very comprehensive. So it's very helpful, especially for our student, because in the upcoming semester, they will take the subject of remote sensing and GIS. But it looks like Dr. Saparas, you're rushing through the presentation, right? I'm sorry, I apologize for the limit time available. So maybe we can organize about the remote sensing and GIS in the next day, or maybe I understand that we to learn about the remote sensing in GIS, it takes maybe in 1 or 2 semester, right? So thank you once again. Okay, here we go. I will share my screen. Okay, can you see my screen, Nabila?
Yes.
Yes.
Okay, perfect. Okay, the title of my presentation is Identification of Mining Area using a Landsat satellite data with machine learning on Google Earth Engine. I took this title from one of my research journal, my paper. Okay, before we delve into the topic of discussion, I would like to share what is the machine learning actually. So here's one of example of machine learning. I believe that everyone here already familiar with it, right? This is Mark Zuckerberg. So this is one of social media application to recognize the face recognition, right? Okay, I would like to provide a brief explanation about what is machine learning. Machine learning, a field of artificial intelligence that allows systems to learn, improve from experience without being explicit programmed to gain the pattern and knowledge. So actually, the system will learn from the data, and computer can learn from it, and that's why the computer would be the smart, so it can make the decision from the data that we provide. Okay, next, I have created illustration to make us easier for us to understand what is machine learning. We can illustrate machine learning as a toddler. Yeah, to read, to recognize the letter. This is the training data. This is A, B. If the shape curve, we call it C, and if the letter it's round, it's called the letter O. It's a symbol of machine learning. And then if we teach our kids continuously, or the toddler, they will memorize or remember the pattern of the letter, right? Therefore, when the child encounter a similar pattern, and they can recognize the letter, because why? Because they already knew it, and they already have a knowledge about the pattern of the letter. Okay, so machine learning is, as I mentioned earlier, is a field of AI, artificial intelligence. Actually, AI consists of 4 basic techniques, namely searching, reasoning, planning, and learning. But we don't talk, we don't discuss about the searching, reasoning, and planning. We focus on learning. But I can give you, for example, technique artificial intelligence in searching. For example, Google Maps. When you find address, you can use searching. And for the reasoning, fuzzy logic. Have you heard about the fuzzy logic? Fuzzy logic maybe in washing machine in our home. There's tools or the function feature of fuzzy. So the machine, the fuzzy will control the rotation of the machine and control the water. So maybe it can save the electricity cost. That's for the example for the reasoning. For the planning, maybe we can found it in the industry. And now we focus to the learning supervised. Okay, wait. We focus on supervised and learning, unsupervised learning, and reinforcement learning. Dr. Saparas already mentioned this about the supervised and unsupervised. Okay. So this is the machine learning workflow. This is from the training data. For example, this is there are various type of number 0, 1, and 2, 9, and then this is the training data, and then we use the algorithm. There's a lot of algorithm such as already Dr. Saparas mentioned, chart or RF, and then SVM support vector machine and K-mean. What else? Maximum likelihood and others. And then the algorithm create the model, and then once we have testing data, and then the model try to identify the number. If correct, then the system will get the correct value. But if it's wrong, and then turn back to the testing data, and then the system will learn about the pattern. Okay, that's simple of the ML, the machine learning workflow. This is the one of the example, just like the Dr. Saparas mentioned before. This is one of my research in Upper Cimanuk. Okay. The comparing image over time and change detection, that's the utilize the benefit of the using remote sensing. This is land use change before and after the flash flood event, and the flash flood event is in September 2016 in Garut. So the 2014, this is the land use, there are forests and agriculture and the settlement and the paddy field and then shrubs. But in the 2015 we have land use change specifically in settlement and agricultural land. So there are significant change took place in the two in land use before the flood event, and after the flash flood incident, the function of the agriculture and the settlement will increase. This is the result of my research, especially in erosion hazard, using the soil type, rainfall, and then the slope and land use and all those the parameter generate the erosion hazard. Okay. Now we go to the Google Earth Engine, or we call it GE. On December in 2010, Google launched a technology called Google Earth Engine. So a GE is a form of integration of remote sensing and big data into a high-performance cloud-based platform and enable fast and easy computing satellite imagery. So the GE provide independent satellite imagery of various spatial resolutions such as MODIS, Landsat, and Sentinel. So basically the platform is built in JavaScript and Python in the handling code. So and also GE can do for the supervised classification and also unsupervised classification. So the machine learning algorithm provided by GE, such as random forest and support vector machine and chart. Okay, this is if you want to try the GE, you can go to your browser and maybe you can click or type Google Earth Engine and directly they will go to the direct this link earthengine.google.com and then click from the menu platform and the code editor. So this is the layout of the Google Earth Engine. So this is the script. We put all the asset, for example, for your ROI, and then if you want to use a script, they are available here. You can type, for example, random forest or maybe Landsat or another script in here. And this is the code. This is the code on script, how to create the training data, or you can import the Landsat or the Sentinel data in here. And then once you finish your code, you can click the run and the result is in here. Okay. So we go to the topic of discussion. This is my research area in Cipatat District West, Bandung Regency. This is Landsat image in 2022. I use band RGB 753, the composite band 753 to simplify interpretation of land cover, or in here is mining areas. Okay, this is to the aims to identify mining areas using machine learning in the Cipatat District, West Bandung Regency, and comparing the accuracy performance of two algorithms, namely classification and regression tree, or we call it chart, and random forest. So this is the definition or description about the chart. Is a binary decision regression tree developed by Bremen et al. In 2017 and used for simple decision making in logic if-then scenarios. So and for the random forest is one of the most commonly used classifier in constructing and assembly classification. So I already found a literature study about the random forest. So the random forest can effectively classify various type of land use and land cover. That's why in my research in Cipatat, or to identify the mining area, I choose the RF and chart. So this is from the reference that RF can give a more accurate classification than current methods. Okay, we go to the flowchart research. So this is the flowchart describing the process to predict mining area in Cipatat district. From the literature study, that's why I choose the algorithm to that algorithm RFN chart, and why choose from the research area Cipatat. That's because the impact of the mining activity in the Cipatat district. And I divided into three part: data set composition, and first we have to import your data to the GE. You choose I choose Landsat 8 in 2022, and then we I get the Landsat from the Google Earth Engine, but the data contains cloud cover. That's why we have to select it with a cloud cover, usually in 5 to 10% to reduce the using cloud masking in GE. After that, we filter the date of the Landsat from January 1st to 2022 to December 31, December 2022, and then area of interest. I import the area of interest of from the Cipatat district, and then clip it the Landsat satellite. Okay, next to the sample point. So to create a machine learning, we have to, just like I mentioned before, that we have to create the training data. So I divide if you want to create mining area. So in this case I use polygon, not a point for the training data. So I about 50 sample in mining, and then settlement and vegetation. So I use 70% for the training to create the model from the RF and chart, and then 30% for the validation. So after the using the algorithm of RF and chart, and then we classify into the three classes, namely vegetation, mining area, and settlements. And then after we classify, we have to validate the model that the classify that we have created using a confusion matrix, and then try to test the accuracy, the classification result using the overall accuracy and the coefficient kappa. So this is the result of the classification to identify mining area, vegetation, and the green one is vegetation, and mining area, the orange, and the red is for settlement. So this is a algorithm chart, and then this is for random forest. Okay, this is the result of the classification. The area about vegetation 102, and then mining area 8 kilometers square, and settlements, and then we compare the chart to the random forest, and overall accuracy is 0.9, and it's not quite significant between a chart and random forest. For the kappa coefficient, we can show the description 0.8 to the very good. So we go to the last one. Conclusion: utilizing machine learning algorithm in an object-oriented approach enables swift and precise identification of mining area. So using machine learning can identify the mining area precise. And the second one is classification using random forest can achieve higher accuracy. It proved by the literature study. Accuracy compared to classification and regression trees, producing an overall accuracy of 93.2% and coefficient kappa of 0.86. 66. Okay, I think that's all my presentation. Thank you. Back to moderator Nabila.
Thank you very much, Mr. Dr. Denny Lumban Raja Eskom MP, for giving us such informative and interesting presentation. And now, we're moving on to the question and answer session. If you want to ask question, please use the raise hand feature or type your question on the chat box.
Okay, there's a question from Pak Adang, Sir Adang, on the chat box.
Okay, the first question is from Mr. Adang Saputra from PEP Bandung to Ms. Saparas. The question is how to interpret and analyze satellite image for mineral exploration, and are there any word examples?
Okay, thank you, Moderator Nabila. And also thank you to Adang Saputra. Okay, good question. Okay, so as I have mentioned earlier, so based on the remote sensing images, so they have a very usually we have to use the hyperspectral images. The hyperspectral images, which is meaning in terms of the satellite image, you must have a very distinct and many of that spectral, because usually the mineral identification, usually what we have to do for the mineral identification is we look into the site first. We have to do on the site exploration, and then based on the ground truth data, so we compare the on-site and also the satellite image, and we look what is the distinct features of each of those spectral in the hyperspectral. So if we have a very distinct of the mineral and also the spectral characteristics, then we can analyze and interpret and identify specifically for each of the mineral. So I have come across of example, but then not in Malaysia, and also I haven't found in Indonesia as well. But they have used it in Japan and also in US. Okay, because the technology of utilizing the hyperspectral is usually the Japan and also the US have that hyperspectral images. So basically, we have to use the image processing, and also we must have also the source of images as well. Okay, and in terms of getting that hyperspectral images, that is also one thing lah, which is okay. If I'm talking about in Malaysia, so in Malaysia, if we want to get a very high resolution images or a very high spectral, hyperspectral images, so we need the permission from the government first, because they want to look why we are doing that at the first place. So usually when we are doing this, we have the collaboration with the certain agencies as well, so that we can evaluate or we can proceed with that analysis. Okay. I hope
thank you.
I answered the question.
Okay, thank you, Miss Saparas.
Okay.
Dr. Paras, you mentioned that you have to get a permit from the government, right?
Yes, yes.
So how about the resolution? Is it quite simple? Which one is better? Sentinel, just like Sentinel, or the resolution of
The
the
Sentinel is
Sentinel is 10 meters,
10 meters, right?
right? Landsat with 30.
If
How about
if we are looking for the mineral exploration, we are talking about the mineral exploration, right?
yeah,
Because sometimes if the mineral have a the vast area of it, then we can identify the mineral. But then if the mineral is less than 10 meters, then that will be a problem, right? Because usually the mineral is very, very distinct and very small area that cover only, if I'm not mistaken.
yeah, that's right. Okay.
And the
If I'm
second
not
one is
okay.
from Ronald Josta. The question is, does GIS can be used to look for any change in environment that include SDGs, such as SDGs 13? How the GIS can help for that?
Okay, thank you again, Moderator Nabila. Okay, thank you, Ron. Okay, Ron is our student in UMK. Okay, he's very active one.
Oh,
Ron.
that's great.
Okay, if Ron
So,
are talking about SDG 13, and SDG 13 is on about the climate action, the economic and social affairs, right? Okay, so if GIS can be used to look for any change in environment, yes, GIS can identify the changes with the help of remote sensing or other source of data as well. Because the GIS alone, it is incapable. It cannot. Okay, it must have a source of data that support the GIS so that it can analyze those changes. Okay, so such as if we are using the remote sensing, then we can do the temporal analysis. Or if you are using the let's say, because we want to look the climate change, right? So if you have those temperature or the rainfall data, so you can integrate all those data and also the remote sensing data, and we can look as a whole how those affected those on the specific climate of your area or your location of interest. Okay, so GIS certainly, as previously I mentioned, when it can have all those information from the remote sensing or from the temperature or from the rainfall or precipitation, then it can make a very detailed analysis. We can look either quantitatively or qualitatively analysis on those data. Then we can make also the prediction what will come next in 10 or 20 years based on the previous data. Okay. I hope that answer my question. The Ron question. Dr. Denny, you can also add.
Yeah.
more.
Okay, thank you, Dr. Saparas. Yeah, actually, in the next year we are, Miss Murni and I are going to research to identify the temperature in one area in Jati Gede, right? Okay. Jati Gede. Yeah, Jati Gede. We're going to use Landsat, and especially in temp infrared and temperature. So and for support the SDGs, maybe for the climate change, we can use it in disaster, maybe for the identification of flood, maybe uh, in in Jakarta, maybe that's for the application of the, or maybe the support for remote sensing in SDGs. Okay. How about Ron? Do you have any question?
Thank you, Mr. Ernest. And the next question is from Miss Moni. Wanna ask Miss Saparas. The question is, how to analyze satellite image for geothermal exploration? What Landsat image are good for analyzing this? And what aerial photography is good for landslide analysis, apart from ultrasound and Google Earth?
Interesting question from Miss
Yes.
Murni.
This is very challenging question.
Yeah.
Okay, this is also new to me. Geothermal exploration. So, if we want to analyze the satellite images for geothermal exploration, so the geothermal, if I'm not mistaken, is actually referring that you are looking based on the thermal band, right?
Yes, thermal band.
Yes. So if we are using the Landsat, okay, if you are using the Landsat 8, okay, that's a different one, okay. If the Landsat 8, it have the, either you are using the band 10 or band 11. It has the infrared band, okay, and the resolution is 100 meter, okay. And also either you because they have a long wavelength, and also the short wavelength infrared. And the band 6 and band 7 are using the short wavelength infrared with a much more high resolution, the 30 meter and also 60 meter. This is also new to me. I haven't explored anything yet on the geothermal, and but then we can use the thermal band from the Landsat 8, or if the Landsat 9, it has thermal infrared bands on band 10 and also band 11. So it can detect everything on Earth that emits thermal infrared radiation. Okay, I think this one probably a good example that can be used for the analysis for that geothermal exploration. And in terms of aerial photography, is good for landslide analysis. Okay, the landslide analysis, if I'm not mistaken, apart from the ultrasound and Google Earth. Oh, Murni, can you explain the aerial photography, meaning the we are looking from the drone or from the satellite also?
Okay, satellite also is no. Area. I'm sorry. Has the Landsat to photography
So,
or
do you mean
Google Earth?
image from the drone
Uh,
or no?
no. Northern.
Oh.
Citra.
Oh, okay.
Oh, Citra.
Satellite
Okay,
images.
okay. All
Satellite.
right. Okay. All right. For the landslide analysis, okay. just yesterday, I have attend for the proposal defense. Our PhD students are looking for the landslide analysis. But then for the dam, okay, it want to look either the dam is risk for the landslide, and the most current technology used for the landslide analysis is using the drone. Okay, by using the drone, we can make the 3D, okay, the 3D spectral and also the 3D of land spectral LSM. Okay, the term is LSM. Okay, and based on the drone and then the point clouds from there, and then it also have to look using the geological engineering by using the piezometer, if I'm not mistaken, look into the measurement of that particular area. Either it has the potential of risk of the landslide. So the chitra that you mentioned is if we are looking for the best or the good analysis for the landslide, I would say we have to go using the drone because the spectral resolution is much more higher and we can very focus on that particular area. Okay.
Okay,
Is
thank
that
you.
okay, Bunny?
Yeah. As a LSM lens surface temperature, maybe. Okay. Thank you,
All
Miss.
right. Okay.
Can
Okay,
I
Bunny.
have add Dr. Saparas? So for Miss Murni, thank you very much. I have conduct research, especially in geothermal exploration.
Okay.
Usually, we use DEM, DEM, from DEMNAS. We call it DEMNAS, Dr. Saparas, provided by our government. The resolution is about 5 meters, if I'm not mistaken. Then for the maybe we generate the fracture density from the DEM, and then we use Landsat to classify the vegetation. Yeah, and then um, we can identify the potential of the geothermal in the area. That's my experience, Miss Murni.
Yeah.
So Miss Murni is candidate doctor, and his topic about landslide, if I'm not mistaken. Is that correct, Miss Murni? So that's why she's interested in landslide using remote sensing, GIS, and aerial photography. Okay, is there any question? Hey, from our student, PP Bandung.
Is there any other question?
Maybe moderator, do you have any question?
Apa?
Pak Priyatna, maybe from the lecture from PP Bandung. So Pak Priyatna.
Okay, thank you, Mr. Lumban, Danny Lumban,
Yeah.
and thank you also on this webinar, the speaker from Malaysia. But Mr. Lumban, I interest in this topic, but I have no experience
Maybe
working with
you can ask about the utilization remote sensing in volcanology, volcanic, yeah.
Yeah.
Do you have an experience, Dr. Saparas?
Yeah.
No,
Because Pak
unfortunately,
Priyatna is
because
expert in volcanology.
wow, that is very
Yes,
interesting.
I'm
Yeah.
volcanologist, but my major in volcanic gas data. So I try to predict the magmatisms by isotopic data. Here's my experience. I know I have researched with Mr. Adang, Mr. Sabtanto, and Mr. Yudi Rahayudin in Dieng because we hope Dieng is next 2 year will be the next geoparks in Indonesia.
Wow.
So if you come again to Indonesia, just I suggest you please come to Dieng in Central Java. The very good view, and there we can study there. So about water, stone, rock, and what is it, gas, and also geothermal. Okay, thank you,
Wow.
Mr. Mr. Lenny Luman, also in our teams. Yeah. Thank you very much.
Pak Priyatna.
Thank you for
Okay.
joining us. Yes.
Yes.
Okay, there is other question from Tariq. He said, how accurate is the GIS on
How
exploration?
accurate? Okay. So, Dr. Saparas, the
Yes.
Tariq asked about how accurate the GIS in exploration.
Oh, okay. The accuracy or how accurate that your data that you can look into is actually all depends on your source of data. Okay. So it also comes back. What are you using for your GIS? Okay. Let's say that for example that you are using the Landsat. Okay. Right. So if you are using Landsat only and it is only the optical Landsat and it has a 30-meter resolution. So the accuracy of your assessment in the GIS for those locations is actually just limited to the 30 meter. So it means that 1 pixel is just referring to 30 meter times 30 meter in one particular pixel. So if your place or your identification or your analysis is looking for location that you want to look, let's say that you want to identify the mineral for location that less than 30 meter, then the accuracy will be very low. Okay, but if your location is in terms of very big area, let's say that it covers for 100 meter or 1 kilometer, then it will be a very good analysis for that because the Landsat is 30 meter and your identification or your analysis cover for more than 30 meter. So the accuracy for your analysis in GIS using the Landsat, then it has a very high, it is acceptable accurate. Okay, so in terms of the GIS, refers to what data that you are using. Okay, or if your GIS analysis is not, because sometimes people always say, we must always have the remote sensing images. No, the remote sensing is actually just one part or one source of data that you can use. Okay, sometimes, let's say, you are not using the remote sensing. If I would say the example for the piping for the water dissemination. Bekalan air. Okay, so if the water supply, they have the piping, right? So those piping is not needed for using the remote sensing images. As long as you have the data of those piping, then it is enough. It's just good enough. So how good your analysis of that GIS based on that piping is based on how accurate the data have been input into your database. So usually we have to look into if that kind of GIS that we are looking to. So it just look into your data in terms how small area that you are looking into, because sometimes the data are looking up to very centimeter level, right? Okay, we want to look, the piping is very either you want to change or you want to do the maintenance and so on, the material of it. Okay, because previously I have those not the problem, but then the syarikat bekalan air in Kelantan here asking for our consultation where how to actually, they want to look how to identify the materials of the piping. Okay, they have all those database and so on, but then they want to just look based on this material, how long is that piping? Okay, so it is actually just in terms of the GIS analysis inside of it. Okay, okay, that is just one of an example. I hope that answer your question.
Answer. Thank you very much about your explanation, Miss.
Okay, welcome.
Okay, if I may add, Dr. Saparas, for
Okay.
the question from sorry. Okay, the accuracy, right? You already asked. Based on your interest area. So the Dr. Sapras mentioned before, the coding they based on your source data, right? If you want to
Yes.
Landsat is 13 meters and Sentinel
Yes.
10 meters, and
Yes.
we have DEMNAS for 5 meters. And if you want more details, you can usually we use drone or the unmanned aerial vehicle to generate the digital elevation model, and also for the ortho photo, right? For the capture from the drone, and then we classify the land use, and then we can use it for the exploration maybe. That's because drone, if I'm not mistaken, two or 3 centimeters. Is that correct,
Yes,
Dr.
yes.
Saparas? So
Yes, correct.
the
Because it all depends on the height of
oh yeah,
the drone.
the
Right.
drone, right?
Yeah. If you have a height or in terms of, let's say, 100 meters,
Mm-mm.
your resolution can be up to 1 centimeter or 2 centimeter. Yes.
Okay, okay. That's the okay. I hope that can answer your question, Tori. So I think there's no more question, Nabila.
Is there any other question? I think that's enough for the question and answer session. I would like to say thank you to all the speakers for the great explanation and to the audience for their active participation. Ladies and gentlemen, before I close the webinar, I would like to take conclusion from what the speaker has presented. The three main types of image classification techniques in remote sensing are: 1. Unsupervised image classification. 2. Supervised image classification. And the last one is object-based image analysis. GIS is a form of integration of remote sensing and big data into a high-performance cloud-based platform and enables fast and easy computing of satellite imagery. Utilizing machine learning algorithms in an object-oriented approach enables swift and precise identification of mining areas. Example, classification using random forest can achieve higher accuracy compared to classification and regression trees. Finally, we come to the end of the seminar. I'm Nabila Fauzia Hardian. As today's moderator, would like to say thank you to all the speakers for the great webinar and to the audience. I hope you have enjoyed this event as much as I've enjoyed it. And Farid, I'll give the next session to you. Thank you.
Well, thank you to the moderator who guide this session, and also to our speakers today. This subject is full knowledge and give benefit to all participants, especially for us, the student of PP Bandung, Indonesia. Once again, a big applause for Miss GSTS Dr. Saparas Binti Daliman and Mr. Dr. Luman Raja Eskom MT. Beforehand, I would like to invite you to all participants to active the camera with the virtual background to have photo group session. Okay, I will count until 3 ready. Active the camera. Once again, I would like to invite you all the participants to active the camera with the virtual background to have photo group session. Okay. I will count until 3 for slide 1. 1, 2, 3. Okay, next slide. 1, 2, 3. Next. 1, 2, 3. Last slide. 1, 2, 3. Okay, thank you. Ladies and gentlemen, that is all the 4 webinar series with PP Bandung. I am Torik, and my colleague Nabila also are the commit would like to ask for apologies if there are any errors in building today's event. And thank all the attendees who has taken to time in today's webinar. See you in next Gypssum. Thank you. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Saparas.
Thank you very
Okay,
much,
thank
Miss
you. Thank you so
Saparas.
much,
Thank you
everyone.
so much. Thank you for all students from UMK.
Thank you for all audience.
Thank you, Sonita.
Terima kasih buat panitia Ariska.
dan suci padamu negeri, Ibu Pertiwi lestari. Senyum semesta indah terkembang, Zuwardi politeknik dan bertambah karya nyata. Bukan tekad, satukan cita, kobarkan semangat bagai pelita. Ibu negeri terus berkarya, Nusantara kan jaya. Bakti dan suci padamu negeri, Ibu Pertiwi lestari. Senyum semesta indah terambah, lajuan di cerah gemintang. Politeknik energi dan pertambangan, karya nyata